Inheritance and subtyping actually play a significant role in the Scala type system and in the libraries for Scala. And it's important to understand this. In fact, understanding it might help you to see some of the things that that you've seen previously when working with Scala. So this is a partial UML diagram, class diagram, of the Scala type system. At the very, very top is a type called any, and everything inherits from type any. We've kind of seen this type come up before when we did something like build a list and we put both a string and an integer in it. And the reason for that is because string is over here and int is over here. And when you build a list that contains those two things, what Scala has to do is it has to figure out what type could be, well, what type is the supertype of both of those. And it always picks the lowest supertype for what you are working with. And so in the case of int and string, the only common supertype is any, all the way up there at the top. Whereas if we were to do, say, an int and a Boolean, it would pick any val. If you picked a string and then maybe put another list inside of the original list, you'd get an any ref. Now over on this side, so these are what are called the value types. The numeric types that you have, as well as character, Boolean, units over here. In addition to the inheritance arrows, this figure shows you some additional lines. Those are for implicit conversions that are part of the library. So there is an implicit conversion. You can pass a char into something that wants to have an integer, and it will be implicitly converted to the integer. Okay? So then a byte will convert to a short, short to an int, etc. Strings convert to string ops, array converts to array ops. Turns out string and array don't really have all of the methods that we call on things, and these implicit conversions give you more. Over here on the AnyRef side, when you write a class, just writing a class, it winds up becoming a subtype of AnyRef. So any other Scala or Java classes you can see are on this side of the diagram, including all of the class types that we've worked with. There's some other interesting stuff going on down here at the bottom. So all the subtypes of AnyRef have a common subtype called null, and this is why you could use null in these values. We try to avoid it. Nulls tend to lead to null pointer exceptions. We don't like having nulls in our code when we can avoid it, but in part to be interoperable with Java, Scala has a null type, which is a subtype of anything that is an AnyRef. And then there's a type here at the very bottom that is a subtype of everything, and that is a type called nothing. There is no value of type nothing. You only get a nothing if you throw an exception, in which case you didn't give anything back, you gave nothing back. The three question marks, because they throw an exception, wind up producing a nothing, and because nothing is a subtype of everything else, it actually works very well in the type system to have those three question marks, because it doesn't force the type to be one thing or another. Whereas like if you have an if and you have two branches, and say one branch returns an int, if your other branch winds up, something goes wrong and it prints something, the print returns unit. Well, if it's possible for one branch of the if to give back unit and another branch to give back an int, the whole thing will have type any val. However, if that other branch, either instead of printing or after printing, threw an exception, that exception winds up giving you back nothing, and nothing is a subtype of int, and so you would actually work with int here. Okay, so this is kind of an overall view of the Scala type hierarchy. We'll come back and we'll see how you actually make classes inherit from one another in the next video.